please visit urbanwaters.in website to find the comic book on Meghdut Enclave, which shows all the best practices to be followed in a layout. Before designing and implementing any intervention, it is recommended to know about your layout in detail. All this information are critical to plan the sustainable water management initiatives in your layout. The main aspects to document are understanding your layout history, the land use and occupancy, the water supply and wastewater infrastructure, the other infrastructures, the neighborhood of your layout, and the present water balance of your layout. Document all the information and update it regularly. This will also help the new Resident Welfare Association when they take over. Now we will go through the above topics in more detail. Understanding your layout history can include what the land was used before the layout development, was there any open wells and are they retained, when the development was completed and when it was handed over to the Resident Welfare Association, the total land area breakup between the different areas, number of villas, the current occupancy and the estimated future occupancy in phases, who is responsible for the maintenance of the layout and who is responsible for the maintenance of common infrastructure like clubhouse. The land use is generally divided into 4 categories: the plot area, road or paved area, park and open spaces, and the civic communities area. For the purpose of this video, let's assume the layout size is 10 acres. If you observe, major of the land allocation goes to the plot area, which is about 55%. The road area is around 30%, parks and open space should be minimum 10%, and the civic community area should be minimum 5%. What are your different water supply sources? How many open wells and bore wells in your layout? How many are dry? How many are yielding at present? And the volume of water available from different sources. Where do you store all the water and how do you supply water to individual houses? Is metering done at all sources like bore wells, open wells, municipal water supply, to know how much each source is supplying and at all critical points such as the inlets and outlets of storage, and consumption metering to know the exact end usage of water. Also identify if any leakages are there in the storage structure and supply pipes, which is essential to know what the real consumption is. Ensure your water treatment system is not an overkill and water quality is monitored regularly at the source level too, in addition to the water quality treatment before supply. Wastewater is another important source of water for your layout. Know how much wastewater is generated and treated, the type of wastewater treatment system, its operation and maintenance, regular monitoring of wastewater quality, the end use of the treated wastewater, and how we are disposing of the excess wastewater from your layout. When we do water interventions, we should make sure our gas, electrical and communication lines don't get disturbed. For better coordination and maintenance, label all your different pipelines, chambers and other infrastructures. It is also very critical to know about your neighborhood. If there are any lakes, open wells, depth of bore wells and water quality in the surrounding areas, and also if there is any flooding issue in the surrounding area. You will have to consider all this in the interventions to be planned. Calculate your water demand, water inflow from different sources, any existing rainwater harvesting infrastructure for storage and recharge, the outflow of treated wastewater and how it is utilized, what is the water scarcity at present or the water scarcity anticipated in future when the occupancy increases. Your water balance depicts how sustainably you are managing the water in your layout. It is very useful to categorize water demand into different types since different purposes require different quality of water. The cleanest water required for drinking and cooking can be categorized as first category. The second category of water required for bathing, washing and cleaning need not be super clean. The third category of water required for flushing and landscape can be utilized from the treated wastewater without wasting the fresh water. In urban areas, per person daily water demand is designed for 135 litre per capita per day. But we have observed that the consumption is sometimes up to 250 to 300 litre per capita per day. For sustainable water management, it is very important to bring down the consumption to 135 LPCD or lower through the interventions which shall be discussed further. Assuming that per person water demand is 135 LPCD, water demand for a family of 4 persons is 540 liters per day, and likewise for the whole layout with total number of 100 families requires 54 KL. RWA has the complete responsibility of taking full knowledge transfer from the developer. Otherwise, there might be challenges in the effective interventions to be planned. Now you know how much water your layout needs, different water sources, the water supply and wastewater infrastructure, existing rainwater infrastructure, and your layout's present water balance. With all this information, let us see what you can do in your layout, how you can meet your water demand sustainably. Now you know how much water your layout needs, different water sources, water supply and wastewater infrastructure, existing rainwater harvesting infrastructure in your layout, and your layout's present water balance. Now let us see with all this information what you can do in your layout, how you can meet your water demand sustainably.
Once you know your layout, we have to see what are the things that you can do to manage water sustainably in your layout. The ideas are always the same, but the implementation changes a little bit. So the things that you can do first is, of course, once you know how much water you consume, you can benchmark it with standards or see how you can reduce your water demand. And how do you get the message across to people, and how do you actually ensure and measure and monitor that the water demand is coming down. You can do rainwater harvesting. In a layout, there are roads, there are individual houses, there are common spaces, built spaces like a clubhouse or a playground. There are unbuilt places like parks or some natural spaces that are there. Water is running off from all of these places. We have to see what can be done at a community level as well as an individual house level to harvest this rainwater. Then of course there is wastewater that is generated from each of the houses. Normally that goes to a centralized STP from where that is treated. We have to look at ways in which that can be reused. Here too we can keep in mind that we are now speaking of a gated layout where there is a centralized STP. But each house can also look at treating and reusing its wastewater in the house itself. Our favorite example to conserve water is always demand management. It's something that we know from our lowest classes, but we never pay much attention to. We're always looking to see, can we bring water from rivers far away, can we dig our bore wells deeper? But really the water that is most available to us is the water that we save. And that is what is called demand management. How do you manage demand? First you have to know what your demand is. Once you know the water that is being consumed by each household, to know that you can install a meter. Meters are available based on your pipe sizes that can be installed at the inlet to your house. You can read, it can be an analog meter or a digital meter, which will then tell you the water that is being consumed in your household. Many times, if you are the MC in a layout, it is good to just collect this information, publish it. The next, that itself reduces demand, just the awareness brings about change in behavior. The next step then is when you ask people to pay for the water that they use. And an important thing there is because the payment is a tool to send across many other messages as well. One is they know that they are consuming more water, so they pay more for it. But much like your electricity bill, where based on the block of consumption that you are in, the tariff changes. What we also encourage is that you build an increasing block tariff, such that houses that consume more water pay a higher rate for the water that they consume. Like with money in our bank, if we were to, the more you want to spend, the other job that you have to do, the other sources of revenue that you have to look out for. But if you just decide to be frugal, and it doesn't mean that you don't do the things that you want to do, you're just very conscious. So an example would be, when I'm brushing my teeth, I don't need the water tap to be running continuously, right? I can use all the water I need to brush or to shave or to wash my face, but I make sure that no water goes wasted. So turn off your taps when you're not using it actively. Houses on an average are it is said that 5,000 to 50,000 liters of water can be lost due to leakages, unfixed leakages in a home over a period of a year. Certainly there are simple things that we can do if we just observe the leakages, or if you're part of the MC, you can conduct audits to the houses, say once a month, or you can just send out notices such that people are conscious of their leakages, aerators on taps or a shower head for your kitchen tap. All of these basically spread the flow of water. In certain aerators there's more air coming out, so there's lesser water being consumed. The water that flows out from a normal tap, by installing an aerator, less than 50% of that flow can be consumed. So for instance, if you have a 15 litre per minute tap, you could bring it down to 6 litres per minute or even lesser. Tank overflows. In a layout, it becomes more complicated because we have centralized overhead tanks, and each house also sometimes has its own overhead tank. There are overflows that can happen at a house level, at a collective level. One is we can be conscious to monitor overflow and turn off the pumps, but many times we are caught in our daily lives amongst the many things that we have to do. So it's always sensible and now mandatory to install a water level controller in our overhead tanks, automatic water level controller, so that any kind of overflow and wastage due to overflow can be avoided. In a home, let's say, especially now that we are working from home, at the minimum we use our bathroom 5 to 6 times in a day, each person, and 5 people in a house, 25 times the flush is being used. Let's say every time we could save just 1 litre of water. How do we do that? You take a bottle, fill it with water, let's say a 1 litre PET bottle, fill it with water, put it inside your flush tank, and what happens then is that every time you flush, you're using just that 1 litre less. In a day, you're saving 25 litres of water. In a month, you're saving 750 litres of water. It's very simple. Scale it out to a layout where there are 100 homes. In a month, 75,000 litres of water can be saved by just putting this one bottle into your flush tank. Yeah, so most of us have a reverse osmosis filter to filter the water before we use it for drinking. That really is to reduce the salts in the water, when it's not for hardness but for the total dissolved salts that are there in the water. The problem with these filters is that close to 1 litre to up to 4 litres of water is wasted for every litre of fresh water that we get for drinking. This wasted water, if you were to check it for TDS, and if you observe that the total dissolved salts, the number is say even at around 500, this water is perfectly okay to be used for any kind of domestic purpose. You could use it for washing your clothes, you could redirect it to your washing machine, you could wash your dishes, you could use it for swabbing your house, watering your plants. You can alternate between all of these uses so that no one place is getting this reverse osmosis reject water at all times. So the message is loud and clear to each one of us. Be conscious of the water that you use. Use it for the purposes that you really need to, but make sure you're not wasting it, you're not allowing for it to leak away, and where possible, you're putting simple mechanisms by which you can reduce your consumption. So we spoke of one of the simplest way by which we can conserve water is just by using lesser of it. If we look at what is the next simplest thing to do, is to just look at the water that falls on top of our heads for no energy of ours at all. We don't have to dig for it, we don't have to get it from far away, we don't even have to treat it. It falls right on our heads, we have to hold on to it and see how best we can utilize it. That is what is rainwater harvesting. In the case of a layout, or in the case of Bangalore, let's say, we know that we receive about 970 millimeters of rain on an annual basis, and we receive rainfall for 6 to 8 months of the year. If we look at a layout now and see the breakup of land, like we've already seen earlier in the Know Your Layout section, we see that about 60 to 70% of the land is in the houses, where each house has some rooftop, some garden. Then a large part of the layout is roads, and then we have common amenities like swimming pools, clubhouses and play areas. Consider a layout of 10 acres. You would be surprised to know that almost 30 million litres of rainfall can run off from a layout of just 10 acres on an annual basis. Out of this, close to 20 million liters of water is running off from rooftops of common areas and other common amenities, let's say the clubhouse. So all this water that runs off from rooftops can certainly be stored and reused, and the other 10 million liters of water that's running off from roads, paved areas, parks can be used for groundwater recharge. Common areas in layouts are always great places to demonstrate any conservation practice that you would like to see. It's available for people living there to come, see, observe and make their own decisions for themselves. This money, the money to implement this, can come from the central budget that is available with the management committee. For instance, and some thumb rules to use are, for the runoff that happens in a layout from common areas, not including the houses that are there, from the common areas, you can go with the thumb rule for recharge of a 10-acre layout needing 40 recharge wells. That means 4 recharge wells per acre of layout. What is the size of this recharge well? Normally it's about 3 feet in diameter and 20 feet in depth. Remember, this is only a thumb rule. The actual numbers will depend on the calculations that would apply to your particular layout, to the kind of recharge rates that you observe in these initial recharge wells that you dig. So the best thing to do would be to dig your first 3 or 4 wells in common storm water drains. Observe the rate at which water goes into the well, observe the rates at which water percolates into the ground, and then actually come up with a plan for your layout at large. Why do we call this topsoil? Because it's soil but which is also rich in organic matter, because the tree litter, the leaf litter that falls on it finally converts to organic matter. The water that percolates into this zone is normally lost to evapotranspiration and hence doesn't count for groundwater recharge. This is from ground level to about 10 feet below ground level. When we go below that, that's where we hit what is the weathered zone in Bangalore. The weathered zone, think of it as rocks that have eroded, weathered over a period of time and have attained a kind of sandy structure. This is soil that you're able to break through very easily, which is really like a sponge. So when we put water into this layer, the soil is able to absorb the water, hold it as well as allow for it to flow. Very simply, we can imagine that this is where our shallow aquifers are. Earlier, when people dug open wells, this is where they got their water from. And this hence is a good zone to put water into the ground as well. In the previous section, we learned about the need to know our rainfall, about the soil below our ground. There's a topsoil, weathered zone, and deep down we have hard rock. In most parts of the city, they are available at 100 feet or below. The water that we get from bore wells actually draws it out from the cracks and fissures that are present in this hard rock. That's the water that we get outside. Typically, this water is thought of as being very old, and because of the minerals that are there in the rock, this water is also hard. Now, when we say recharge, we are really trying to put water into the shallow aquifer as well as the deep aquifer. To put it into the shallow aquifer, recharge wells are our best allies. What is a recharge well? It's a hole into the ground that goes into the weathered zone, 20 to 30 feet deep, dug by the well digging community called bovies. It also provides an opportunity for livelihoods for them. The well then is lined with readily available concrete rings for structural stability. These rings are stacked up one on top of the other, and then you place jelly stones or big stones all around in the space between the rings and the soil. These stones are sterile, don't put any organic matter there. What you're trying to do is, because these gaps are present, fill it up tightly so that the well does not collapse. Initially, it's good if these wells in a layout can be placed in storm water drains, because that's where most of the runoff happens. Once the well is dug, on top, cover it with a concrete slab. Make sure the concrete slab has some kind of opening such that you're able to look into the well to see if water is going into the well, to monitor the rate at which water is flowing out of the well as well. For another level of safety, it's good that you place a grill below this concrete slab, such that if for any reason the concrete slab were to break, there is this grill that also provides additional security. In layouts, in common areas, these recharge wells could be located in the drain, on the drain itself, such that they are able to capture the flow of water in the drain. If your drain is very narrow or is a closed pipe, you could even locate it just off the drain. So what you do then is you build a small check dam in the drain. From there you give a pipe which takes the water into this well, which is off the drain. Make sure, since in the drain there can be leaf, one is make sure there is no solid waste in the drain, but to keep the leaf litter out, you can build a small sill trap or put small jalis in the drain which continue to filter the flow of water as it flows in the drain. So remember, wells in the drain, off the drain, in parks and other common spaces. You can also look at a strategy of direct borewell recharge. Here we are trying to put the water into the borewell directly. How do we do this? So you normally dig a pit around the borewell. I say it's like a recharge well. So it could be 3, 4, 5, 10 feet in diameter based on the space available. You need not go very deep. 8 to 10 feet of depth should be sufficient. This pit is again lined with rings, but here the difference is that you fill the pit with stone aggregates as well, and in the borewell casing you make perforations which will allow for the water to go in. Along with these perforations, also wrap the perforations with Netlon mesh. Now what happens is you can take water from a nearby rooftop, allow for it to come into this pit, pass through these aggregates, through the Netlon mesh, through the perforations in the borewell casing, fall deep down into the deep aquifer from where this borewell used to draw its water. Some things to keep in mind: do this kind of direct borewell recharge only for borewells which used to yield and have now gone dry. It is preferable that you don't do it for a borewell that is currently yielding. Remember, whatever is the quality of water that you put into this direct borewell recharge is the same water that will come back to you. Here there is no possibility of the ground further filtering your water, which is why sometimes recharge wells are better dug in public places, because we may not always have a control on the quality of water that is coming in. Here the weathered soil plugs in to help us because it is able to filter the water. Like we already mentioned, 60% of any gated community is actually owned privately, is part of the houses. So then automatically the larger efforts for rainwater harvesting can be done at each household level. Let's take the case of a 60-40 house or a 30-40 house. So if you are a 60-40 house on 2400 square feet of land, annually you can harvest close to 200,000 litres, 180 to 200,000 litres of water. What can you do? Make sure your rooftop is clean. Take your rooftop water, whether it be a sloped roof or a flat roof. If it's a sloped roof, install gutters. It's better if you do this at the time of constructing your houses. But if your house is already constructed, no worries, you can always install gutters. Gutters can be of various types. They could be made of PVC, you can have stainless steel gutters. Bring that water down with a down pipe. You can do it very aesthetically in the form of rain chains. They look very beautiful bringing the water down if you don't want a PVC pipe. Filter this water. Again, you could filter it with a homemade filter that's really made of a container. That could be a plastic drum, or it could be something that's made of ferro cement or some cement and brick masonry work, inside which you have layers of aggregate like charcoal, wood charcoal, clean wood charcoal, aggregates, Netlon mesh. Filter this water, hold it in your sump, in an existing sump, or if you want to make a new rainwater harvesting sump, that's also okay. This water can be used for all domestic purposes after filtering, and after filtering it or boiling it, you can even use it for drinking and cooking. Filters, like I said, can be what you put together like a DIY filter, or you can even purchase a ready-made filter off the shelf. There are several filters that are now available in the market which can filter rooftop water, which are wall mountable, hence very easily installable. Maintenance of course is required, but the filtered water can be let into your sump and you can use the water for all your domestic purposes. If the sump is small, or if your roof is large, or if you have a large garden, also look to see if you can make a recharge well somewhere in your house. Overflow from the sump can go into this well to recharge groundwater. We get this query that in my house I don't have a bore well, why should I do groundwater recharge? Yes, you need to do it because it's fairly likely that your layout is getting water from a common bore well. If each house in the layout could do its bit towards putting water into the ground, you are ensuring that the community borewell gives you water for much longer. So wastewater treatment and reuse starts at home. If you look at the wastewater that is generated in a home, you could look to treat it in your house itself and use it. In fact, treatment becomes a lot easier if you're not using chemical detergents. Here there are soap nuts. If you plant a soap nut tree, or if in the layout there are soap nuts, see if you can use them to do your dishes, to wash your hair, to wash your clothes. And then the wastewater is not of a quality that needs any kind of treatment at all. You could use it directly to water your plants. In most layouts, however, there is a common STP, and wastewater, which includes black water from your kitchens and from your toilets, as well as your bath water, washing machine water, goes to a common STP, a sewage treatment plant. Sewage treatment plants can be of multiple types, some which are electromechanical. That means they need electricity to keep running and there are moving parts. They use technologies like activated sludge process, sequential batch reactors to treat the water. You could also have nature-based STPs which rely on soil, plants to treat the water. But the final output is treated water, and it is our responsibility to make sure that treated water is reused. Treated water in a gated community can easily be sent back by doing appropriate plumbing to each of the houses, where the houses can use it for gardening in their houses, or they could even use it for flushing. If you do have excess wastewater, treated wastewater that is available, you could look at giving it to a neighboring farm. There are cases where there are local farmers who are willing to buy this water or just take this water for free. You could look at treating it to further water quality and either selling it or giving it to an industry or any commercial establishment, malls that are looking to run their cooling towers, corporate offices that are looking to run their cooling towers. That is a very easy end use. You have to make those partnerships to see where it can be used. There are some gated communities who also use this water to water the newly planted saplings outside their community, in medians, in public parks. So look for opportunities where this treated wastewater can be used. In our city, there are entrepreneurs who are now willing to set up that tertiary treatment plant in your own campus, on your land, at their own cost, or if you'd like to pay for it, you can pay the upfront capital cost, but then they treat the water to drinking water quality standards, and you have options of either buying that water from them or just taking it or selling it. All of these options become available to you. We can never over-exaggerate the need for communication. What you see is that in a gated community, there are people who are coming on rent. There's always movement, people that come and go. These practices, whether it be around water demand management, rainwater harvesting, wastewater treatment and reuse, we need to talk about this over and over again. There is one round of conversations that are required initially when you need people to come together and invest in infrastructure for each of these units. But subsequently, there is a need for maintenance, there is a need to just know about these systems. So we can never overemphasize the need for communication. It could be in online ways. You can have webinars, WhatsApp messages, posters that you circulate. You try and see if you can organize events, or maybe on a 26th January, 15th August, where you have a large group come together, talk about the need to conserve water and what are the various things that you can do for the same. Try and connect with neighboring gated communities, or in fact, even now there are associations of gated communities across the city. Learn from their best practices, share your best practices with them. You can always look up a lot of this information on bengaluru.urbanwaters.in, where you learn about what are the various, one is you learn about the rainfall, the geology, you also know about the service providers in your city, but but you also learn how it is that you can do rainwater harvesting, wastewater treatment by yourself, or who do you reach out to for help.
It's very important to remember that when we manage our water and our waste, we stand on the shoulders of people who we call labor. So it's very important to recognize that our partners in all of this are the plumbers, the well diggers, the masons, the sanitation workers. And it's important that we respect them, that we give them dignity, that we ensure their safety and their insurance, that they are sources of knowledge, and that we invest in their knowledge and in their skills. In good water and waste management, it's very important to monitor and document things very regularly. So be it your sources of water, how much they are yielding, what the levels of water are in your wells and in your bore wells, regularly monitor them and document them. What the quality of water is, regularly test your water once in 6 months, once in a year. Keep testing and keep monitoring. In good water and waste management, it's very important to monitor and document everything in your system regularly. It's very important to constantly monitor the yield of your bore wells, your depth of your wells, bore wells, or all your sources of water, the quality of all your sources of water. It's important to monitor and document the performance of your STPs, of your recharge wells, of everything that you have in your system. Have a regular system of monitoring and documenting it. Here again, your laborers, what you call your laborers, are a very important part of this whole monitoring and documentation bit. You need to invest in their skills so that they become a part of the monitoring and documentation, so that they bring their everyday stories of your STPs, wells and bore wells into your documentation process, and you are able to capture the knowledge that they bring into this process. Equally important and good management of your water systems is regular maintenance. Regular maintenance, for example, of your recharge wells, where you look at it once in 3 years to look if it needs desilting, if it needs some rings to be replaced. Here again, well diggers are going to be our partners, and remember that they are sources of knowledge. They can make observations to bring you insight into what's happening, and they are not just people who dig your wells. Similarly, in your rooftop harvesting systems, make sure your catchment is clean, look at your filters regularly, clean the filters regularly, and observe the quality of water that's coming out as a result of harvesting your rooftop rainwater, and get it tested once in 6 months or once in a year regularly. Then, when you're maintaining your STPs, remember that the sanitation workers who are going to work there put themselves at great risk. Ensure that they use the appropriate set of personal protective equipment, and make sure you're not violating the PMSR Act 2013. That is the Prohibition of Employment of Manual Scavengers and their Rehabilitation Act, where you have to make sure that nobody is sent into confined spaces where there is sewage or fecal sludge. This can put their life in danger. Make sure you're very ethical about how you maintain your STP, notwithstanding some incremental costs. Just to summarize all the good practices in water management that you can employ, think of the entire journey of water, from where it begins to where it ends after you use. So you begin with your sources. It may be your bore wells, your wells, municipal supply, even tanker water supply. But do you understand your sources? Do you understand your well? Do you understand your bore well? How much does it yield? Which bore well is the most important bore well in your layout or your apartment? These are very important things to capture, right? These are things where you have to invest in understanding. So that's your first step in good water management. Secondly, understand what your demand is. Who's consuming how much? What is the water being consumed for? Can you actually reduce your consumption? How can you reduce your consumption? Can you make your taps more efficient with fixtures? Can you actually become more conscious about how much water you use and reduce the water you use? Are you sure you're not leaving your tap open when you're brushing your teeth, and you don't really need to have the tap open. All these are very important things, and all these are often a result of constant communication with the community you are working with. So that's very, very important. Finally, if these stories and if these messages need to go and sink into everybody's heads, meter every consumption point. Every household can be metered, and so that every individual, every household understand how much water it's consuming and becomes conscious about the water it's consuming. So metering, and then setting appropriate tariffs and setting volumetric increasing block tariffs, meaning to say that everyone pays based on how much water they are using, and you are recognizing that the first n,000 liters, which you can decide for your own community what that n,000 liters should be, but that is everyone need to use. It's a right to life. But for every bit of water used beyond that, you begin to send signals to the community that they are either being wasteful or they are being conscious, and let your tariffs reflect that, and let therefore your water bill become a story you communicate, you use, the water bill becomes a way to communicate this story to the community, right? So this issue of managing the demand is extremely critical, because if you manage your demand, if you reduce your demand as much as you can, then be it managing the supply of this water, be it managing the wastewater that you generate, then becomes that much simpler. It becomes that much cheaper. It can make the difference in a community between investing in a 250 kiloliter per day wastewater treatment plant and a 150 kiloliter per day wastewater treatment plant. It means completely different economics, and therefore this issue of managing your demand should be considered very, very important. As you work for managing your demand, you can actually start looking at each household within the community as a place to harvest rainwater. Rooftops are usually clean surfaces, so you can capture rooftop water, store it in tanks, and the household can actually use it. And this much water the household now does not need to depend on the community's water supply. Similarly, water that's falling on clean roads or water that is not being able to be stored in storages from rooftops can all be let to recharge wells. So you can capture rainwater from common catchments and private catchments which you cannot store, and ensure that you recharge groundwater, because we are all dependent on groundwater, either through wells or through bore wells. When we are recharging water, however, remember that the quality of the water we are recharging should be clean. We should ensure that it's not getting mixed with sewage. We should ensure it's not getting mixed with solid waste. We should ensure we should put our recharge wells in appropriate places, not very close to electrical cables or sewage lines. Then, apart from rainwater harvesting, you should look beyond the journey of the water when it leaves your house, right? So all the water that you've used and is going out, can that be treated well? Can you actually separate grey water, that is the water that simply has soap, and black water, that is the water coming out of your kitchen or your toilets? Can you actually separate them and treat them separately? You should consider these options. And the water that's treated, can you at least use it for gardening? Can you at least use it for flushing, thereby reducing your freshwater demand? And again, having that virtuous cycle of saving on both resources and costs, because your demand is low. And in doing all of this, remember that plumbers, masons, ring makers, sanitation workers, well diggers are all our partners, and we treat them respectfully. We treat them as sources of knowledge and not just labor. We invest in upgrading their skills. We invest in making them a part of our solution and our solution thinking process. All of this goes to making a sustainable community, and sustainable communities make up a sustainable city. So all these practices, when you implement in your community, it may not happen overnight. It usually never happens all at one go. It takes perseverance. It's usually an incremental process implemented over time. And most importantly, it's also a process where all the residents within the community are bought into these ideas, know what these ideas mean, and it's a process of persuasion of one and everybody who then come together to implement this. And to do all of this, there is www.bengaluru.urbanwaters.in. It's an online repository of all sorts of actionable know-how, information, and helpful contacts for you to be able to implement all these good practices in your community.